Let's start this session about testing on Android. First, a little information about myself. My name is Philip. I work as a consultant for a company called AppFoundry, and I work as an Android developer. My first Android app I made in 2009, and it was a scheduling app for the DevOps conference. Yeah, it looks quite 2009-y, but that was basically one of my first experiences with Android apps, and I've been busy since then. So what do you need to know more? Well, I work as a consultant, so I switch projects from time to time. And basically, the reasoning why I wanted to do a talk about testing on Android is because I have seen quite a couple of projects where there was no testing or very little testing at all, and where, while working with the app, it became obvious that a little more testing could have been helpful. So that's maybe my why, or why I'm interested in testing an Android. I hope that when you leave the session, you know a little bit about what it is, and especially how you will do it on Android, because this is basically the reasoning behind testing on Android. When I make an app, and I work lots and lots of hours on it, I spend quite a lot of effort, I would really like my users to behave a little bit like this. They use the app, it's working perfectly fine, it really is doing the things they expect to do. But we see quite often that users get a little bit angry because on their device something is wrong or something is totally off in UI and so on. And that's why I hope that when we talk a little bit about testing, you will be able, if you use the information from the session, to not have too many users reacting like this. Now, another reality on Android is that you have lots and lots of devices available. So that also means that there are lots and lots of devices you should test your application on. Okay, this is a little bit of an exaggeration. You shouldn't test it on an iPhone, but it's the only picture I could find with so many devices. But really, that's one of the extra difficult things when you think about Android and testing. There's a very, very big amount of devices available, and I hope that when you leave here tonight, that you also have a little bit of an idea how you can work with how you can make up a strategy so that you still feel confident, although you might only have 5, 10, or 20 test devices, but you should still be able to feel confident that your app will work on every device. And also, more towards the end of the session, I will talk a little bit about, well, you've spent time writing tests, thinking about how to do it. In the end, I think you should always try to strive to a solution where everything is more or less, or is automated as much as possible. So that's also one of the topics we'll talk about today. All in all, why would you do testing? You want to avoid as many problems as possible. When your app is released to the market, you should try to find every problem while you're still in development. And so I will really talk about the tools and libraries. I will talk about quite a few libraries. Of course, I cannot talk about every library, but I think I've made a selection of the most useful and the most used tools in Android development. And I will also not really talk about, well, we have a test person in the team, because I heard a colleague say, writing tests, my test is called Dirk, and the tester is taking care of it. But I really think that's doing your tester a disservice. On my project I'm currently working on, we have an excellent tester, a very good tester, but I find it quite useless to have him go through scenarios 20 times a day. Oh, I need to test something on screen 4, takes me 2 minutes to get there, and so on. So really, a lot of testing can be done in an automated way by your computer. Testers are super important, and it's very nice to have a good tester on your team, but really try to use those people not to do some dumb monkey testing all the time. Let them spend their time as wise and as good as possible. So, because whenever you read about studies about testing or when you have bugs, what is the cost of fixing them? Time and time again, we see studies coming up where, yes, if you want to do testing, it will take a little bit time setting it all up. It will be a little bit of an upfront effort, but in the end, it will really pay off. And especially when you take a look at the average bug fixing time, you will really see that when you have a good test suite, a good testing strategy, a good regression testing strategy, it will really help you all along. Now, this is when you look about, when you search on the cost of fixing defects on Google, you get more or less 16 million results, and most of them have the same tendency. So I really hope that's a little bit making the case for why you should test. Really, because you want to mitigate the issues when the app goes live in the App Store and the Play Store, you really want not too much or not too many bugs showing up anymore. Now, let's make it a little bit interactive. And maybe do a little show of hands. Who here does Android development? Okay, quite a lot of you are. Who of you is writing tests? Okay, not so much. Who of you has even never written a test until now? You can be honest. No? Who is an Android developer and has never written a test for his or her Android project? Okay, you are honest. What's your t-shirt size? For you? Yeah, sure. Okay. Anyway, to make it a little bit interactive, whenever you have a question, feel free to ask. There's also going to be a little bit time at the end, but to encourage you to ask questions, and because you were so honest, I have a t-shirt for you. Anyway, excuses. I think the main excuses we always hear about why aren't you writing tests and why are so few of you Android developers writing tests. There are a few main excuses. The old one, we never make mistakes. Well, I hope to meet some people like that someday. I know for sure that I'm not in that category. Also, functionality is trivial. That's also something you hear quite often. Whoa, it's only a simple project. Or this is so simple, I can't make mistakes. Quite often, we start on something small, and all of a sudden, it gets snowballing, it becomes a bigger project, and so on. I think it's a little bit dangerous to say, this is so trivial, I shouldn't have a test for it. Another reason that you hear quite often is, tests slow you down. It's maybe a little bit, that's for some reasons it can be true. For starters, it's some new things that you need to learn. So when you just start out writing tests, it will be new to you. So you will need to spend a little bit of time on it. But when you get proficient in it, I wouldn't say it's a big time drain, especially when you then start getting the experiences that when you're working on bigger projects, having a good test suite really helps you along. Like if you're writing some new functionality and you have tests saying you that you broke some old functionality, it's very nice to have a test suite in place to warn you instead of, well, catching it when it's too late. And yeah, the old one, management won't let us. That's sometimes the most difficult of all. Now, I hope that, especially for testing on Android, you will find out in this session that it's quite easy to do, quite easy to set up, quite easy to use. And I hope that if you're convinced that testing can be important, I hope that you will be able to convince your peers to take it on your projects. Now, if you are writing about tests, what do I think are the main traits, main characteristics of a good test? I think every test should be isolated. One test shouldn't depend on another test. They should all be able to run independently. You should be able to run only the tests for the class you're working on instead of running the whole test suite, and so on. It should also be repeatable. It should be fast and self-documented. And let's get into some of these. First of all, repeatable. Whatever IDE, whatever platform, whatever operating system every developer on your team is using, everybody should be able to run the same test suites. That's paramount, I think. And also, it shouldn't really depend on the environment where you are running. If you are running the tests on your own development machine, or it's running on a test or a continuous integration server and so on, that should all be possible with the same test setup. Another trait of a good test, I think, is speed. For the main reason that the less time it takes to run your tests, the less time you have to get distracted, and the less of an interruption it is to your workflow. I've made a small video. This is a screencast of a screen capture of the current project I'm working on. This is part of our tests that are running, and you see that there are a little over 1,200 tests that are running in more or less 14 seconds. And so that's really, I have no excuse anymore not to run at least this part of our test suite before I do a commit, for instance. So I should really run all these tests before I do a commit. I should never make the code break on our development branch. And that's one of the, when I have a fast test suite, I can really run it all day long. I can run it tens of times a day. It's not really slowing me down, and it gives me great feedback about the work I'm doing. Now, we will see in this afternoon that some tools lend to very fast tests, like these. Some are a little slower. At the end of the session, you will know where I got these from. This is only part of our test suite. The long-running tests, for instance, could then run on the CI server, or the very long-running tests, we could run them every night and so on. But having a fast-running set of tests with you that you can run all day long is really helping you a lot. And then also self-documenting. I really believe that if you have good tests, it really helps you to understand your code. First of all, and I'll get back to that, is if you write your application in a good way, in a good structured way, in a good architected way, I think it will be clear code. Same goes for your tests. But if you have a good suite of tests, well, you already have like a good set of documentation. You don't really need to explain every class anymore. You don't really need to write a lot of documentation. You have documentation. People can just read the test suite and get a feel for how your class is working. And basically, that's already a good start set of documentation. Now, these are what I think are the four main traits of a good test. There are other topics that are quite interesting to have for your test suite, and you can keep these in consideration while we go through the tools. But I think it should be easy to execute your tests. It should also be easy to debug, and I cannot stress that enough. If you have tests, but it's very difficult to debug when some tests fail, you will just not write those tests. So the tools I've selected, those tools also make it very easy to debug a test that is failing. Also, they should be realistic. You should be able to run them on real devices, emulators, and also when you get, for instance, a report like, oh, on one device we have something strange going on. Most of the time it will be a Samsung device, but you should be able to write a test case for it and then run it on a real device and see how it's behaving. It shouldn't be a system that's only running on a very special environment. Also, well, in Android land, we know that there are a lot of customizations done by OEMs. Various OEMs have skins on top of Android. Again, Samsung is the biggest alteration, I would say, but it's very good if you have a test suite that you can start running on real devices and see if your carefully crafted logic or UI really is working everywhere. And also, and you will see this getting more and more important as we progress through the session, if you have a fluent API or a nice API to work with, that will really invite you to just work more with your testing tools and write more of them. So as we progress, you will see that easy to write tests is getting more and more important. And then I would say, well, I really believe that having a good suite of tests is a measure of the quality of your project. Lots and lots more things that are important, of course, but I really believe that testing is important for basically every app. Now, as said, you as Android developers, this is going to be your environment. Lots and lots of devices, lots and lots of different form factors. So I hope that I can present you a story that will help you to write tests and manage all the different environments and configurations your app will run in. I will not really go very deep in theory. 2 more minutes and we will really start digging into the tools. So I will not really make a lot of theory about, well, the different types of tests are, and also not like very much about, well, if you have mocking, what's the difference between stubs, mocks, spies, and so on. I really want to present you the most used tools for testing on Android. And if you're interested in picking it up, I think that's more useful than talking more about a lot of theory. The only thing I wanted to say is there are 2 big groups of tests, what we call black and white box testing. That's maybe just interesting to know, because some of the tools will fall in either of the camps or in both. Now, who knows what the difference is between black box testing and white box testing? Yes? Yes. What's your size? L. Anyway, come pick it up in the pause otherwise. I have a lot, but they're not really well sorted. But like he said, the big difference between black box testing and white box testing, black box testing basically means that you don't really have knowledge about the application. White box testing is the opposite. So you know about the internal structures. Most of the time, you just have the source code. So we will mainly start talking about white box testing. That's what you will do as a developer most of the time. Black box testing means that you could even start testing other people's applications, because if you don't really need intimate knowledge or you don't need the code, then you could just as well say, I'm going to take another application and I'm going to see how it behaves and start writing tests for it. Anyway, so let's wrap this up and start looking at the tools. We'll talk a bit about real unit tests, we'll talk a bit about integration tests, and then we also talk a lot about how you can test your UIs. That's basically the most interesting thing for you as an Android developer. And then at the end, we will try to bring everything together in, like, if you want to run big test suites on multiple devices, or if you want to run your tests on a CI server, and so on. But now, let's stop with this testing theory and start looking into the tools we have on Android. And the first one is, well, you could say, let's take a look at the developer.android.com site. Type in or search on testing, and this is the first page that will come up. So, testing fundamentals on Android. Let me first say that the documentation about testing on the Android side is not bad, but it's also maybe not excellent. And there's also, they could use some more. So I really hope that there's place for what I'm going to tell in this talk. But let's first see what you get from testing tools when you use the Android SDK. The first thing to know is that the testing tools in the SDK are based on JUnit. And we will talk about the system to test your application is called instrumentation testing. Another tool that you will find in the SDK is called Monkey, and there's another tool called Monkey Runner. Now, Monkey Runner is a Python API to test your Android applications. I don't know a lot of people that use it, so that's one we will not talk about today. We will stay in Java land, but for your use case, it might be an interesting one. Now, as I said, Android testing is based on JUnit 3. People that have done a little bit of testing on Java until now will know that the current version for already quite a long time is JUnit 4, but what we get for now, and later on a little bit more, but for now, when you stay with the normal tools, everything is based on JUnit 3, so that means that your testing methods need to start with a certain prefix called test, and if you want to do a setup and then a tear down after your tests, you really need to override a method called setup and a method called tear down. Now, let's take a look at the first test. Let's say I'm going to write a test with the normal tools in the Android SDK. So you see, I need to extend test case. That's the base class and JUnit 3. And then you see that if I want to do setup, I need to override the setup methods. So that's basically the skeleton for the normal Android test. And then, of course, you can write your tests, make sure that they begin with the test prefix, and then the test runner will be able to pick them up. Now, as said, we have JUnit 3. Of course, if you write a test that is not really testing any Android resource, then you can, of course, write a plain JUnit test. You only need the Android testing classes when you are really doing something with Android. But everybody knows that a lot and lots of times you need things like context, activities, resources are passed around all the time. So for that, the Android tooling team made the Android JUnit extensions so that you can really start writing tests that test your Android components. And the base class for that is Android test case. It extends the normal JUnit test case. And the second big group will extend from instrumentation test case. You see, they both extend from the normal JUnit test case, but these are the two big groups. Now, let's talk about instrumentation. What is instrumentation? Basically, instrumentation makes sure that the testing system has hooks into your Android application, and it can also control your application lifecycle and monitor what is going on in your real application. The way it works is, when you write tests, basically you are writing two applications, your real application that you've been working on along all the time, and then the test application. And the reason instrumentation can work is because they are both deployed on your device, a real device or an emulator. Emulator really doesn't matter for this story, but both of the applications are deployed in the same process, and that's why the testing application can start instrumenting your real application. And so it's possible from your test application to invoke the methods of your real application, and then of course, if you modify fields, you will also want to examine what is going on. So basically, if it's coming. As said, it runs on a device and an emulator, that's all the same. The good thing to know is also that you can, of course, mix these up. If you have multiple devices and emulators connected to your development computer, instrumentation tests will make sure that your tests are executed on all of them in parallel, so that's nice. You can use it either from your IDE. What I will use this afternoon is Android Studio with the Gradle build tool. I think that's the thing to do nowadays for Android. But of course, whatever IDE you have, or you can of course also run them from the command line, which is, for instance, what you could maybe do on a server and so on. And so it allows you to do various interactions with your app and so on. Now, let's take a look at a little bit of code. First tests. How can it look when you write for a test for Android? Basically, the main entry point will also always be get a hold of an activity, of the activity that you're testing when you're doing a test of an activity. So you really need to say get activity so that it gets started. And now, basically, what the test here is that we're writing is, everybody knows if you have an Android application, when you change the orientation of your device, the activity will be destroyed and then recreated. So let's write a simple test to check that maybe I had a spinner, a combo box on the screen. The user selected a certain position. Of course, when the user changed orientation, he still wants to have the same selection. That means, and I suppose everybody that has done a little bit of Android development knows that you can do state changing and state restoration. So this is what we are going to test here. Is the selected item saved well, so that after the orientation change, the same item is still selected? So you see, we get a hold of the spinner. This is normal find view by ID code, which you've written hundreds and hundreds of times by now. I set a certain position. After that, I will stop my activity, so I know that my activity will be destroyed. And after that, in my test, I will immediately restart the activity. And now I know that my onResume should be triggered. And if I have done my work well, if I have saved my state well, I should have written my activity so that the position gets restored. So let's write a test for it. I get my current position now, and then I can write an assertion, assert that the current position equals what was, well, what I expected to be. The two main groups in Android, and that's a little too fast. Now, the two main groups on Android of tests are really the Android test case and instrumentation testing. This is a little bit of a misleading diagram. You can't extend those two classes. Basically, test case extends from assert. But what I wanted to tell here is that when you are writing tests with the instrumentation framework, you can have a few assertions already available to you. So that's what's available in the Android SDK. And, well, I have a small diagram here. You can do assertions about equality, logical assertions. You can check if something is null or the same, and so on. After that, it's also, if you're working with UIs, quite often you will want to check the state of the UI. So that's why the Android guys have given you a class called viewAsserts, with a few extra asserts that are really handy for UIs. For instance, you can assert that a certain view is on the screen, and so on. So that's a handy one. I've taken a screenshot because that's all there is. This is the whole API of this viewAssertions class. It just fit on one slide. Now, I will not talk too long about plain instrumentation tests, because there's just a lot more interesting stuff available than this. But what can you test? What are the base classes for your tests that are available in the Android SDK? Basically, if you look at Android test case, you will see that they have a few classes extending it. So you can test application objects, you can test content providers, you can test background services, and so on. So these are all test cases that are available to you. And on the other side, if you really want to work with the instrumentation system, if you really want to have your test app instrument to real app, you will most of the time extend from something that's coming from instrumentation test case. Now, the main class you will use is called Activity Instrumentation Test Case 2. The people that were thinking about the naming of classes had a holiday that day, I suppose. There is an activity instrumentation test case. They've made a better one, and they gave it a really unfortunate name. But this is one you will use quite often. So as said, it can really help you. All the main types of Android components that exist can be tested with the instrumentation testing framework. It's also good to know that you can isolate your system under test from the system. For instance, we all know that if you do a little bit of Android, you know that context is passed around everywhere. If you, of course, want to write a test for a very specific part of your application, all these Android building blocks can be mocked out. So resources, context, content provider, and so on. The testing framework has mock classes for all of these, so you can really write isolated tests for basically whatever component you have. Now, very fast. Let's take a look a little bit more concrete. This was more a theory behind instrumentation tests. Thing to know is that when you want to run tests, you need a test runner. The good thing is that if you use Android Studio and the Gradle build tool, this is all configured behind the screens for you. This is the default. So I've just written it out what the default is, but you should never even enter this. So it says that the Android.test.instrumentation test runner is the test runner to use for all your tests. So let's take a look. Basically, the first instrumentation test we could do. If you want to test activities, fragments inside activities, and so on, you will see this is happening a lot. I'm writing a test. I extend the activity instrumentation test case 2. It's generic, so I need to tell for which activity it's working. And then basically, you just write your tests. Now, I have made two super simple examples so that we can focus a little bit on the testing tools and not really on the rest of the code. The first one I made is a simple app that I can use to do some temperature conversions. And let's say that our American friends here, I want to tell them how good the weather here is this week for this time of the year. So it's a full 12 degrees Celsius. If I want to tell them how many that is in Fahrenheit, I've written a small app for that. So that's the first step we're going to take a look into. And then a second one is a very simple master detail screen. Say that you want to know a little bit more about your favorite characters of your favorite show. So that's the second example we can use a little bit during this afternoon. And both of them are so simple that we can more look into the tests instead of the code. Now, let's start with the first one, temperature conversion. I'm going to switch from time to time a little bit between the presentation and some code samples. So, presentation, right. So let's take a quick look into the application. Basically, it's super simple. I hope you can all see it. I can make it a little bit bigger. But I have a super simple class to do my temperature conversions. And then I've written a very simple activity on top of it. So let's take a look. My converter activity. Now, basically, it's very simple. You've all done it a few times, I suppose, if you've done 5 minutes of Android. You see that I have what you saw on the screen. I have inputs, a button, and I also use my temperature converter class. Now, let's take a quick look. I will just show you a little bit Android Studio. I hope this font is big enough. Otherwise, give a shout. I can make it a little bit bigger. But the thing to know is, first off, this is the emulator I use. I use Genymotion most of the time during development. So if we take a quick look at the application, I can just build it quite easily and deploy it. So let's check it. 12 degrees Celsius is still 53 Fahrenheit. So this is what we are going to use as the first example to write some tests. Now, right, let's write a test for this. Here you see that what you already saw in my normal, in the application code, and which you know from doing some Android development. During the setup of my test, you see that I get hold of whatever I need from my application. So if I want to get all my text fields, if I want to get my button and so on, I need to do all my find field by IDs and store them as fields in my class. And you also see that, as I said, you need to do get activity, so that real application activity will be started by the instrumentation framework. So basically, it's already the first thing to note. That's already quite a lot of boilerplate, and I'm not even writing tests for the moment. I'm just setting everything up. Now, let's write a test. So, what am I doing here? This is what I could say is a test for my temperature converter application. You see that I use the touch utils and I tap on my Celsius input field. Then I can send it some keys. So I just send 1 and 2. I want to input 12 degrees. And then I touch my convert button. So that should do some things. And then, of course, I will see and I will test and I will check whether the application is behaving right. So I'm doing that here. I am checking what is the result of my computation. So I'm grabbing it from the Fahrenheit output field. I know what it should be. I know what the Fahrenheit equivalent is of 12 degrees Celsius. And then I do my assertion. So the actual end result should be the same, should be equal to what I expect it to be. So this could be my first test for my temperature conversion app. Now, we'll take a look into the code again. We'll play a little bit in our editor. But what is good to know is that these types of tests are just integrated in your tools. So if you use Android Studio, if you use Gradle, what we saw until now is just integrated in your base setup. That's also for people that are doing Android for a little longer. It used to be when we were on the Ant tooling and in Eclipse. Most of the time you would start a second dedicated project for your tests. That's not really the case anymore. Everything is nice, integrated in one project, and the Android tooling will make sure that the two apps are built. So the real application, testing application, and both will be deployed on the device, and the test app can instrument the real application. And basically you will see that we have two source sets. The main one that you should all know, because that's where you are writing your code. And then, if you write your tests and you put them in an Android test directory, that's basically a default, and that's the one where the Android tools will be able to picking up without additional efforts by you. So the Android tooling will then make sure that the test application is built, everything will be deployed to the device, tests will be run, and at the end, both apps will nicely be removed again. Basically, you can all do that in your IDE. You can, of course, also do it command line. So we'll take a look into that too. You can give all these commands command line. So let's take a quick look. Let's mirror my screen here. Right, Android Studio. So basically, this is the most simple Android application I could think about. You see that I have my classes over here. Basically, the important one is the activity. This is my main source set, and you see just on top of it, you have the Android test directory. You see that Android Studio is smart enough to pick up. So this one is blue. It's just Java source code. This one has a green coloring. So that's the indication that Android Studio sees or knows that this is the location where it can find your tests. So basically, nowadays, if you just start a new project in Android Studio, you will even get this one generated for you. So you really don't have the excuse to saying, I don't even really know where I should place my tests. Nowadays, this is generated for you. But now let's take a look. So this is how you could start writing some tests. I can show a few, but you see that you can already do quite some things. Let's make it a little bigger. So you can already do quite a lot. You see that I can, for instance, when the application starts, all the fields should nicely be empty. I can also make sure that certain fields are on the screen. That's good to know, because if you deploy your application on so many devices, it might be that some of your users is using a super cheap device with a very, very small display. So if your requirement is that certain fields should be visible, then you can write a test to make sure that you've developed it well. You can also do some things like, well, is the alignment okay, and so on. So this is basically some, basic instrumentation testing code. You also see that you can tell it to run on the UI thread. You all know that on Android, the UI thread is the only thread that can do alterations to the UI. So let's see, this is a very small scenario. So let's see what is going on. I request focus in my Celsius field. You see that I put a certain value in it. Then you can work with it and you can do your assertions. Now, how can you run this? Quite simple. You all know this, of course. You can run your app, but if you click on a test, you can, of course, run your tests. So it asks me now if I want to deploy it on a device. Let's do that. And I'll quickly change to my device. So you see it's executing my tests. For the people that have good eyes, you can see at the bottom it says tests passed. So take a quick look. So basically, this is the nice overview of my tests. It says that it has detected 7 tests, done all of them, and I get nice feedback. And this is especially important, of course, when tests are failing. So basically, this is it. This is how you will set up a normal project, write tests, and run them. Now, you can do the same command line. So take a quick look at how that is working. Let's take the right project. Now, for the people that don't know all their commands, put it a little bit higher up. So if you use Gradle, you can just ask, well, what tasks do you know about? So if you just start out, it might be helpful to once in a while ask Gradle, what do you know? And yes, interesting ones are here, of course, the verification tasks. This is what we are going to use for our tests. So you see that it has, for instance, connected check. So the documentation says runs all device checks on currently connected devices. So let's give it a shot and let's try this out. So yes, I have a currently connected device. So let's take a quick look. So, okay, this is my project. And it said I need to run the connected check command. Again, let's take a look at how my device looks. So you see, it compiled the app, compiled the test app, and then it says I'm running your tests, and you see that it executed all the tests. So working fine, whether you're working in your IDE or when you want to try stuff out command line. Right. So we've seen the command, we've done our first looking around in the IDE, how you do your test, how you write them, how you run them. It's also good to know that for your tests, you can add additional dependencies. So let's say you want to use Guava, the well-known Google library full of interesting and very useful functions and classes to work with Java. Let's say I want to only use that for my tests. I can nicely declare that this dependency is only going to be used for my test classes. So I have the Android test compile dependency. Until now, you've had the compile dependency scope. So you see that you can also add dependencies only for your tests. Now, running. So we've basically seen it. The Android tools will make sure that both of the apps are built, run, install, and nicely uninstalled at the end. And as I said, multiple devices, the instrumentation testing infrastructure will nicely take care of it. And the command, as we've seen, is Gradle connected check. Now, good to know is that when you run tests, you also can generate, or you get a test report generated. First version is just XML, so that's nice on your server. When you, for instance, do CI, you can have your, you can parse those, you can nicely extract the results. This is located, we'll take a quick look, but this is located in your build folder. You have an output folder wherein you will find the Android test results. But more useful for a developer is something like this. You also have nice HTML report generated. It's located at build reports Android test. And this is how it's looking. So you get a nice overview, you get your test summary, and you can also nicely go into them. So quickly take a look. Yes, it's mirroring. So, as I said, I'm in my temperature converter project. I get my XMLs. What's more useful is this one. I have my reports. Seen it? When you open it up in a browser, you see that you can nicely go into your packages, and it's definitely interesting when you have some failing tests, but even for every test class you write, you can do a drill down and see for every method what the result is. So that's quite handy. This is generated by default for you. Sure? No, and it shouldn't have an impact on the other tests. It will just always start up, for instance, in this case, the activity, and at the end of each test, I will destroy my activity again. So even if you have written 10 tests for the same activity, the activity will be spun up and destroyed again 10 times.
And when an exception is thrown, what happens?
Well, here in this case, for a normal tooling, when you have an exception, when you have a fault, your tests will stop then and you will see the exception. But a little later on, we will see better systems to run all your tests and get a nice gathering of whatever went well, whatever went wrong, and how you can get all this together. Right. It should show the presentation, of course. Now, to wrap this up, the normal Android instrumentation test before we go on to some extra or additional tools. There are there are a few drawbacks and especially limitations that you have as long as you're working with the normal Android instrumentation test cases. First of all, well, you need to have a certain set of knowledge. That's how it's going most of the time with new tools. It's not really a drawback or a limitation for instrumentation testing, but you will see for the other tools that they just try to make it a lot easier to get to know them. Also, and this is an important topic when you are writing tests, the whole notion of flakiness. If you write tests and you run them, they should hopefully always work. If you have test cases that sometimes work, sometimes don't work, you didn't really change a thing, that's really going to be frustrating, that's not really going to be helpful, it's going to be going to take a lot of your time. And one of the problems that you have, as long as you stay with normal instrumentation tests, is that sometimes it's very difficult to know in your test what you should do. For instance, you will see that if you would only use these tools, quite often you will do things like thread sleeps and so on, which I find very dirty. And that's really not helping you to write a robust set of tests. So that's really one of the drawbacks. And also it's quite complex. I mean, the things we've done until now is basically super simple, and still we had already quite a lot of boilerplate. It was not very readable and so on. So it's complex, and also tests are not running really fast. Yeah, also one of the reasons for that is, of course, because if you do things like, I don't really know how fast the test is going to go, the second activity, when is it going to show up, I'll just wait a bit for it and so on, that's really going to make your tests slow. And so, of course, what's also necessary is, you've seen that I really need to know my application. When I want to grab a certain field, a certain view, I need to know IDs, I need to know certain properties. Sometimes you need to work with, has it focus and so on. So really, you really need very good knowledge about the app you test. And then again, also certain things like opening up menus and so on. I think you will need to do a Google search the first time you try to do that. So it's not super helpful. And also because, yeah, you really need to couple it to certain IDs and so on. That means that when you start doing some heavy refactorings of your application, it will also quite often mean that you will need some refactorings for your tests because they are quite tightly coupled. Now, the first new tool is called Robotium. That's already a tool or a library that's quite old. It's one that we can already use for quite some time. And basically, it's a testing framework on top of the instrumentation framework. And the goal of it, the intention is really to make it easier to simplify the task you have when you are writing tasks. So it's really the intention. If it's easier to write your tests, hopefully you will write a little bit more tests. You will not have a lot of excuses not to do it. Robotium also tries to help you a little bit with the whole story about automatic timings and delays and so on. For instance, you have one activity, it should transition to a second one. Instead of just waiting, we will see that Robotium has a little bit nicer syntax and a little bit nicer tooling around it. And this is where you will first see a very big difference, how you can find views. We'll see that Robotium is quite handy. And all in all, that also will make your test execution run a little bit faster, so that's also quite nice to have. Now, the main class in Robotium is called Solo. I really don't know where the name is coming from. It's a strange one, but that's how it is. And this will really be your entry point into Robotium. So what you see here is when you do a setup of your test class, you will make an instance of Solo. You will give it the instrumentation and the activity. So basically, let's take a quick look in the API that you get from Robotium. Now, what you see is you can quite easily get a hold of views. Get view, get button, get image view and all. You see that's already quite nice, quite easy also to work with your UI. It's also very easy to do some interaction like clicks and scrolls. You can quite easily send keys. You can type. You can do certain checks, like for instance, a certain checkbox, as it a check state and so on. And also, and that's sometimes also very useful, you can take screenshots. There's a little bit more than what I have here. These are only the most interesting or the most used functions. So really take a look in the Solo API docs if you're interested in Robotium. So let's rewrite the first test we did. If you still remember, we were basically testing this scenario. Now, remember, this is what we had until now. First of all, a whole slide of just boilerplate, and then a second slide where I had my real tests. So you see, it's not so readable. I already have a lot of code. Same test could be done in Robotium in basically this way. There it's coming. So Robotium really has the idea to make your testing code more readable and make it easier to write. What you see here is that with Robotium, through the Solo instance, I can just enter text. I could get a hold of my input field, and here we see that this is more, as you said, black box type of testing. I can just say in my first text field, enter the text 12. I didn't need to grab a certain text field. I didn't need to know the IDs. At the same time, this means that your test might be a little bit more brittle. You really need to think, is this what you want to do? But at least you can do it with Robotium. Then you see, second line, click on button, which has the text on the button convert. So again, I really don't need to know the IDs and so on. It's very nice and easy to write a test. I just say, if you find a button with convert on it, click on it, and afterwards I just do an assertion. And what I do is here, I ask Robotium, search for a text field which has 53.6. If you find that, in this scenario, I'm happy that this will be the output. This is, of course, maybe not the most robust test that you can write. I've just done this mainly because I wanted to show that with Robotium you could eliminate a lot of the boilerplate and you could really start making more concise and more readable tests. Sure?
Text on a button, is the text which is displayed to the user more likely to change than the ID of the button?
Yeah, absolutely. That's why I said this is more like I want to do like shocker slide, see how easy it is to write Robotium. But in a real world scenario, I would, of course, for this case, I would also use IDs because most of the applications we write, especially in Belgium, where we have more than one official language, you will have localization and so on. So it's not maybe the best test to match on a certain text on a button. Anyway, how can you use Robotium? Of course, it also has a dependency. The good thing to know is that this is the only thing you need. You need to put the library on your class path, but for the rest, we'll just use the normal SDK test runner, so no changes there. So basically, the only thing you have to do is, as we've seen until now, you can add dependencies, especially for testing. So this is what we are going to do. we're going to add Robotium. It will not show up in the real application. It will only be used for the test app. So, since you always need to get hold of the solo class, if you use Robotium, I would just say make yourself a base class for all your Robotium tests. Could look a little bit like this. So, well, basically you extend the activity instrumentation test case 2, what we had until now. And then you make sure that you make an instance of solo. So in the setup, you get hold of your solo, and then in the tear down, you can make sure that all the open activities are nicely finished and closed up. And after that, you could then write your tests. Now, let's take a quick look at a few other highlights of the Robotium API. It's also, for instance, quite easy to work with lists and so on. So you see that the second application, my Big Bang application, I could just say, click on a test, Howard. I don't really need to know if it's position 3 or 4 or whatever. You can just say, click on a certain view. You can also say, well, I know I want to go to, I want to click on position 3, for instance. So you can also do that, but that's already quite handy that you have all these shortcuts and useful functions in Robotium. Also, for instance, let's say you have a menu or you have an action bar with an overflow. Well, I could just send it, for instance, a menu key code. At that point, my overflow should open up, and I can, for instance, click on the info. Also useful to know, that was too fast. Let's say you want to test between activities, what is happening between activities. So I can do that with Robotium, and quite easily. So you see that I can assert. And then, for instance, what Robotium will do is you can do methods like wait for activity, and you can see if it's showing up. So here what I'm doing is I first check that my first activity is really coming up. Then, for instance, I could click on Howard, and at that point, his details page should pop up. So you see, I can do that with Robotium quite easily. The only thing is I still need to think a little bit about what is the timeout that's possible. We will, in a few moments, see another tool that makes even this quite a lot easier. And the good thing is also that when you use a tool like Robotium, you also get error messages that are more useful to you. For instance, let's say I try to get hold of a button. A little bit your comment. If I have a button and, well, the text doesn't fit with my test, then you will get an assertion failed error, but the fault or the error message is quite clear. It says I have a button with text. Test button is not found. So that will really help you when you are debugging or taking a look into failing tests to see what is going on. Also good to know is that Robotium can interact with WebView. So if you have an application where you include a WebView, it's possible to use Robotium and test those cases too. So basically, you can get hold of the pieces in your WebView. For instance, like get web element, click on a web element, enter text in a certain web element. And the selection can be based on things like IDs in the web page or class names and so on. Now, let's take a quick look how this looks in an IDE. So let's mirror the screen again. Right. So again, this is the code I showed you on the slides. If you want to see that it can run, well, let's do it command line this time. So again, the command to run is connect to check in this case. And we should see some more tests going on this time. And then afterwards, we can do a quick look into our report. So, as I said, you can also interact with menus, what have you not. It could still run a little bit faster. That's it. Successful. If I take a quick look then at the output. So, this is what you have. So you see, I've run 17 tests. The rest is coming later on, but you can nicely do a drill down in my Robotium tests. I have some Robotium tests here too, so my conversion still works, and I had quite nicer and easier code. Right. Next up, until now we were really working with the UI and making it a little bit easier to do some inputs and do a little bit of work with it. But of course, when you write tests, it shouldn't only be, I want to do some interactions in an automated way with my application. At the end, you should of course do assertions, check if at the end of the test your app is in the state that you expect it to be. So don't assume, always write assertions for what you're doing. Now, a little extra tool again, a handy tool to know is, until now it was a little bit hard with the tools we had until now to do some of these assertions. We only had a few, like assert true, assert same, assert not null, but we didn't have a lot more. It would also be nice if we had a little bit more of an expressive way to do our assertions. So another tool is Hamcrests. This is also quite a well-known tool for everybody that's done some testing on Java. And basically, we will work towards a syntax that's more like this. Assert that, and in this case it could be assert that the audience is paying attention. So you see, that's already a lot more readable. Also easier to write because your IDE will be able to help you. But so you see that it's also possible for your assertions to have some tools that make life easier for you. So you can use that to do your verifications at the end of a test. So what is Hamcrests? It's a library of what we call matchers. And basically, as I said, it's syntactic sugar on top of your matching. So basically, now when we introduce Hamcrest in our project, we will be able to do things like this. So assert that certain string is equal to an expected. And you see, this is already a lot and lots more readable code. So really handy to have. So what you do is you assert that an actual value at the end of the test, for instance, and you compare it with, well, what you expect that the value should be. So, again, for strings, this is what we had until now, just to make it clear again. Until now, we only had the assert equals expected with some string. You always have the problem if you didn't use it for a few days, what's coming first? Actual, expected. Anyway, with Hamcrest, we can now nicely write assert that some string is equal to expected. Now, Hamcrest, the more and more you work with it, the more and more you work with tests, the more and more useful it will be. For instance, let's say that you have a collection. In this case, I have my collection of Big Bang characters. Let's say I want to assert something about the first person. Until now, I could say assert equals. I have a certain person in my test. And then, for instance, let's get hold of the first item in my collection. You can already start thinking, what if I don't need the first one? With one later, I will still need to add a for loop and so on. With Hamcrest, you just get this. Assert that a certain collection has an item, and then the one I want to match on. So really, Hamcrest will help you in with a much nicer syntax and a much more fluid way of writing your matchings. So basically, again, what do you have in Hemcrest? The most important functions of Hemcrest. What's in what they call core is you can do this is matching. Very useful is a logical matching. So if you have multiple matchings, you can, for instance, say all of those should match, or any of all these should work out. I have an example a little later on. You can also match on objects. Very handy. If you have a collection, you can see if a certain item or a certain group of items belongs to a collection and so on. And if these are not all what you want, you can also quite easily write a custom matcher. So it's a very big collection of useful matchers, but let's say you have something that's not inside Hemcrest. Let's write a simple scenario for a custom matcher. So let's say we want to write a test to see if the square root of -1 equals not a number. You know that the double class has the not a number. So let's say we want to write something like assert that square root of -1 is not a number. Okay, no problem. We can quite easily write a custom matcher. Can look something like this. So you extend the type safe matcher. We say we're going to work with doubles, and as the comment says, we will basically check if a double has the value not a number. So you see, in matches safely, I can just do my logic. So that's basically it. That's for the Hemcrest matching. You see, it's quite easy and quite easy to write a custom one. After this, I'll go on with an extra tool. There's a question.
Yep. Just wondering if there's a reason why you chose to demonstrate Hemcrest over something like assert J and assert J Android.
Well, I have assert J a little bit later on, but the reason I'm showing Hemcrest now is that next slide is going to talk about a new framework where Hemcrest matches are very important. So that's why I wanted to do it. But you are definitely right. In the test project, I have assert J going on too. But the next one I want to talk about is Espresso. And I hope in a few minutes my detour around Hemcrest matches will become clear. So Espresso is one of the newer testing frameworks. It's a framework made by Google. It's also an abstraction layer on top of instrumentation testing. Good thing is you can use it since API level 8. I really hope nobody here is still making apps where you need to have them running on Gingerbread, but that means that you should really be able in your projects to start using Espresso. And it's released now more or less 1 year ago. Google has a Google Test Automation conference, and last year it was presented. Basically, the story behind Espresso is that one of the internal teams in Google also thought, well, this whole testing story could be a little bit better, so why not make something that is better? And that became Espresso. It's an open source framework, and you can, this is the link to the site. Now, one of the reasons behind Espresso, or one of the characteristics of Espresso, is also it has a fluent API, so it will really help you in writing nice tests. The good thing is it's extensible, and it's extensible because it's based on Hemcrest matchers. So that's why I did a detour. It's also quite fast to have your tests running. And it also has a very nice debugging and especially logs when something is going wrong. So it's very useful to have. So basically, when you're writing tests, what will happen quite a lot is you will find views, you will do some things with the views, and then at the end, you will check the state, for instance, that view. So since you're doing that so often, that's you will see Espresso will really help you. Without a lot of boilerplate, without things like additional timeouts and so on you need to worry about. And basically the API is super simple. Let's start with, most of the time, you will say on a view with, for instance, a certain ID, a certain text on it, and so on. Or, and we will a little later see why, but when you work with adapter views, say you have a list view, you have an adapter behind it, when you want to select a certain row, for instance, in a list, it's very well possible, since Android does recycling and so on and only uses rows that are visible, it's possible to say, well, I want to work with the on data so that I can get hold of an instance that's maybe not visible. And then when you got hold of a component, you can work with it. So either you can do things like click, center text, and so on, or you can do your matching. Basically, find stuff, do some stuff, and at the end, you check the state. So let's take a quick look at some of constructions you can make with Espresso. Basically, a simple one to start. You say on a view with ID, some ID. On that view, perform a click. This is super readable code. This, because that's also very important if you write tests. It shouldn't only be easy to write, but it's also very good if it's easy to read, if the rest of somebody else of your team is coming in and can quite easily see what is going on. So this is really a very expressive way of writing a test in Java and still have super fluent API. Another one is on a view, and instead of matching on an ID, let's match on a certain piece of text. So on view with text, and then I do a check. Matches, I do a match it, and for instance, one of the matches that we can find in Espresso is it displayed? Is displayed is, by the way, an interesting one. It's not only is the visible property of the component visible, but it's also is the item, is the view visible on the display. So again, super simple code, super understandable. Here a little bit more. So again, on a view with an ID, check, and you have lots and lots of useful matchers in Espresso. For instance, in this case, check that basically it matches with a certain text that contains a string. So you see, you can really, in a fluent way, quite easily drill down into your components, into your app. And then the other one is on data. So as said, if you have an adapter, you can say to Espresso, I want to work on a view that corresponds with a certain piece of data. So in that case, you can write on data is, for instance, a certain object, and again, perform a click operation. So this was really very simple, very understandable code for your tests. So the on data one is used if you work on a list. So if you remember again the Big Bang application, master detail, list, you click on an item in the list, you go to the detail page. Let's say, for instance, search for a row. So I want to check the row. I want to get hold of the row corresponding to Sheldon. So on data has, and then the toString for that one will start with Sheldon. I want to perform a click. So very simple. You can go quite a lot further. So like on data is instance of, it's an instance of one of my Big Bang characters. At position 5, perform click. And also useful, you can also drill down in child views. So let's say you know that the Big Bang application was a picture and then the name of the character besides it. So on data with a hash toString that starts with Amy, I want to get hold of the child view with an ID, the photo. And on that image view, I want to perform a click. So even if I want to drill down into child views and so on, it's still very readable code. It's still very understandable code. And because it's a fluent API, you also have your IDE that will help you and suggest the possible methods at each place. So really, really interesting and helpful library when you do your white testing. This is a little more elaborate example. Let's say you have multiple views and you want to do swiping, so right, left swipes. Let's say you want to write a test for it. So, okay, let's do it. You see that we start with a check. So when the app starts, we should start in position 0, of course. So on view with a text, let's say these are all screens and they have a text position 1, position 0. Okay, let's do it. On view with text position 0, check that it matches is displayed. So we've written a test to see that our app starts at the first position. Then, okay, do a swipe. So on view with an ID, the pager, I can perform a swipe left. Again, these are all commands that are available to you when you use Espresso. So let's do a check then. When you've done a swipe, we should have moved up 1 position, so let's check that. Swipe back, no problem. Again, we can do a swipe right at that moment. Do a check that we're again on position 0. And then, of course, position 0 should bounce and should not be able to go further anymore. So, okay, do it. Do an additional swipe right, and we should be at position 0. So we've done quite an elaborate test. And the test code is looking very readable, very nicely, and it was not really difficult for us at all to write a test like this. You can also do scrolling, of course, like scroll to. Also interesting to know, the example here is that on the perform, you can pass multiple actions. So if you know that you want to do multiple actions, that's all possible for you, and that's all available in the Espresso API. And basically, this is the whole Espresso API, how you need to know it, how you need to think about it on one slide. As said, you always will work with these on views and on data, and then you do an interaction, and at the end you can do view actions and assertions. Now, these view matchers, as I said, I did a detour around Hemcrest because Espresso uses Hemcrest matchers. So when we do filtering of these views or when we make assertions on views, we use Hemcrest. That means that you can quite easily also reuse whatever is in the Hemcrest library that's available. Besides that, of course, if you don't find what you need, you can still write your own matcher. So Espresso comes with an additional class called view matchers, which is, of course, Android-specific view matchers, which you wouldn't find in the Hemcrest core library. A quick screenshot. There's more available in view matchers, but you can already see that it contains quite a lot of useful functions, like you can match on with a certain text, with a certain ID. You see things like is enabled. The one at the top is displayed. So really, you get quite a lot of useful functionality out of the box with Espresso. Now, since it's based on Hemcrest, we already saw that Hemcrest also has support for logical matchers. That's also quite useful if you're writing some tests for your UIs. Now, this is a simple example. Basically, what you need to focus on is, let's say that you have a text field and you want to have multiple conditions. So I do not want it to start with X, Y, Z, and it should contain ABC somewhere in the text field. Still, for a requirement like this, it's quite easy to set up and it reads quite nicely. On a certain view, you check that I match all of, and then I have my 2 matchers. Same, of course, for if you want to have conditionals. I want to have a text field that ends with XYZ, or it should contain ABC somewhere in the text field. You can just work with any of. So quite nice functionality and still very well readable. Now, these view actions is what you use to then perform actions on your views. The good thing is that Espresso will guarantee that they run on the UI thread. So things like input of text, scrolling, and so on is all supported by Espresso. Besides that, you can also quite easily make your own custom actions. Let's take a quick look. Let's say that you would want to write an action whereby a text field is cleared. That's a little bit a bad example because this is already an espresso, but it's a simple one just for documentation and illustration. So let's say I want to write a clear text action. Okay, I will implement the view action interface. So I say I need to implement the get constraints. You see, I can work with Hemcrest. I say for this to apply, it should be displayed. It should be on the display, and it should be of the type edit text. And then you see I can do the perform. I can just say set text to an empty string. Just to make it then a little bit more useful, I can just wrap it in another class so that I can write a method like this. Let's say I have a test. My test is called test clear Celsius text field. So I can say on a view with a text Celsius perform and then my custom view action. I can statically import it because I wrote a static method for it. So I can just say clear text extra thoroughly and that's it. So even if what you need is not in Espresso by default, it's very easy, extensible. It's very easy to write some of your own functionality. And then a quick detour. Espresso claims that they have better reliability for your tests because they do synchronization. Not only claims, that's how it works. Basically, what Espresso is doing for you, that's what you get from Espresso, is they do synchronization between your tests, your instrumentation tests running, and the UI thread of the app under tests. So basically what is going on behind the screens when you use Espresso is Espresso will make sure that it waits until the app is idle, and only then will it perform its actions on the UI threads. That's very handy, that's very powerful, but that also means that Espresso is basically looking in the event queue of your main application, and the moment it sees that work is done, it can immediately go on with the test. So it doesn't need to wait a certain amount of time. It is really looking inside your application. When the app is again idle after it's done some work, you can go on in your tests. What also good is that, you will not always have all your logic running on a UI thread. Sometimes it's important on Android when you have a long-running task, you pop to a background thread. Espresso will also need to do synchronization. The good thing is that certain things can be done by Espresso. So if you use, for instance, the async task class, well, Espresso will by default synchronize with the thread pool behind an async task. If you, of course, have your custom logic, if you have your custom background services running, you can work with the idling resource interface. So that's the way that how you can signal again to Espresso, my work is done, now you can go on in a synchronized way with your tests. This is basically what you could implement. I will not go very deeply into it because I would like to urge you all to go to another session after this one. When this session is finished, there's a dedicated Espresso session. So I think if you're really interested to go a little bit deeper at 4:45, there's another session starting dedicated to Espresso. So I will now move on to just how do you set it up, how do you use it in your tests. Basically, Espresso will also have dependencies. And it comes in two ways. You can download it in more of a standalone way, so that means it's bundled. Espresso with whatever dependencies it has, whatever dependencies it needs of itself. Or you can, of course, use it as a separate library, and then you will need to make sure that you supply it with the dependencies you need. That's, for instance, very handy because Espresso uses Dagger underneath for dependency injection. It uses Guava and so on. So if you have these dependencies already in your project, you can still work with it. The problem is that the way Espresso is released now, how you can find it on the Espresso site now, it's not so easy to work with. Well, It's not difficult, but I mean, it's not working out of the box with Gradle the way you would like it to be. You can't really find the dependencies somewhere in a nice repo. So let's first take a look at how the Espresso documentation would suggest to use it. Basically, you would need to add the necessary files as libraries in your project. And then, of course, we know we can do that with the Android test compile scope. And then whatever additional dependencies that are needed for Espresso, these you can, of course, use in your normal fashion. So you see that Dagger is used, Guava is used, Hemcrest is used. And then, since in the library you can find a certain file that would otherwise be in the project multiple times, you will need to exclude it. Anyway, the good thing is that quite a lot of people are already using Espresso. So a lot of people were thinking about, can't we wrap this up a little nicer? I'm going to focus on Double Espresso. That's basically a repackage of Espresso by Jake Wharton, who's just made sure that you can more easily use it as a Gradle dependency. So he's called the library Double Espresso. So if you see Jake Wharton Espresso, you can just add that as a dependency. With the normal way of excluding groups, you can, for instance, say, oh, I already have Dagger in my project. This doesn't need to be brought in as a transitive dependency. And there's, of course, it's split up a little bit. So, for instance, if you want support, if you want Espresso for a support library, it's an additional dependency. Now, one additional thing you need is a custom test runner. Until now, we could just work with the normal instrumentation test runner. When you start working with Espresso, you will need to use the custom test runner. It's called the Google Instrumentation Test Runner. But again, we've already seen that it's very simple to work with a custom test runner. If you use Gradle, you can just include it in your build.gradle file. So you see, now in a default configuration, you will need to make sure that Gradle knows about your custom test runner. It's looking like this, and this is all basically you need. So it's still not difficult to set up Espresso for usage in your projects. And basically, the reason that they use a custom test runner is because they have so much going on behind the screens, like better control about the life cycle of the app, improved error logging, making sure that that whole synchronization story is working, and so on. So they wanted to have a better, more reliable way of working with Android testing. The custom test runner isn't really a problem. And the good thing is that the Google Instrumentation Test Runner extends the default test runner. So even if you have a mix of normal instrumentation tests, Robotium tests, and Espresso tests, just use the Espresso test runner, and you can run all the other types, of course, too. So that's good to know. You can use it with all the other libraries we've seen until now. Now, this is quite fresh. 10 days ago at the DroidCon UK conference, there was an announcement by a developer advocate from Google about Android and testing. I've not seen a lot about it online or so, but the good thing is that soon, and soon is undefined, but unofficially, it's going to be really soon. But there's going to be an Android testing support library. So you already know about the support libraries we have on Android. There will be a new one dedicated to testing. So it will be a container for whatever Google already has from testing frameworks. As said, it's going to be called the Android Support Library, open source, and very good news. It will come with full Gradle support. So what I said until now, if you want to start writing tests tonight, you might take a look at these slides, how you set everything up, but we can really hope that in a few weeks we will have very great support for testing. Now, what is in it? In the testing support library, it will contain a new test runner, and the great news here is that instead of only supporting JUnit 3, we will now also get support for JUnit 4. So that's great news. And then it will be a bundling of Espresso. Then I have a slide too about Intento, what it does, and UI Automator. We will not really talk about UI Automator, but that's also a Java library that you can use for testing. I wouldn't really use it if you're for most of your testing, because Espresso is just so nice to work with. But it's what's very good about UI Automator is that you also can quite easily go to other applications and so on. For instance, a use case could be, okay, I am making an app. It should have networking. What if I could simulate that I go to my settings app, I turn off my Wi-Fi signal, and at that point I run my test. So for these use cases, you could quite easily use a UI Automator. It's also Java-based. And so JUnit 4 support will be handy. So whoever knows JUnit 4 will recognize these annotations. So again, hopefully in a few weeks, we will be able to use these for our Android tests. There will also be support for parameterized tests. So let's say, for instance, you write a temperature conversion. You could then write up a whole list of inputs and expected outputs for certain calculations. And instead of writing all these tests, you could just give them as parameters to one test. And all those pairs are then tested by the testing library. Now, it will look something like this. So again, the dependencies will then become something like Android test.support supportlib. We don't really know what the version is going to be, but it will be more or less this. So very simple. We don't need to do any additional things. It will nicely play along in our Gradle setups. And then also at the same time, we should see a new version of Espresso 1.2, which also has quite a lot of extra new and very nice features. For instance, things like with Espresso until now, we couldn't really test web views. Full support for that is also going to come in Espresso 1.2. Again, the official message here is soon. After the talk, I don't know how sure we can be about that, but it should be here in a few weeks, hopefully. Now, as said, a test runner. For Espresso, we just use the dedicated one from Espresso. Good thing is also with Espresso that you have nice error messages. So it's a bit of a wall of text, but the important part is in green here. And it just says, no views in hierarchy found matching with text is Celsius. I've written it with a C instead of an S here. So, and the rest is your view hierarchy that you all see dumped out. So really, Espresso is also trying to think about what if you have an error, what if you have a fault in your tests that are running, how can we be of help to find what is going wrong quite easily. And then another tool that you will find in the new Espresso release is called Intento, and this is really to do this inter-application testing when you are jumping between screens and so on, and when you are working with intents, which every Android developer will know about, how can you test these? So basically, you will be able then to very easily intercept intents. So let's say on your screen, you use an intent to start the second activity. You can capture these outgoing intents and validate them, of course. So you can then quite easily write tests to see if a certain intent in the right way has been sent. You can also go the other way around. You can say, well, I now want to write a test. This activity should be started with a certain intent. I'm going to nicely mock this up. I'm going to nicely stub it and then see if my activity reacts in a way I expect it to behave. So it's quite nice that we will have these coming on. Maybe let's take a quick look before we go further, how it's looking in an IDE. Right, let's mirror the screen, otherwise you won't see a lot. Right, so let's see. This should be readable. So, still, I extend from activity instrumentation test case. It's an instrumentation test. We just have all this nice sugar on top of it to make it a lot easier and nicer to write tests. But whatever we've seen until now is working quite nicely. Now, let's take a quick look at how you can run these. So I again do my connected check command. This is going to do all my instrumentation tests. So at the end, I should see my espresso tests show up in my report. Yes, it's doing all kinds of works, but let's take a look how it's configured. So we know we have your build.gradle file. And so you see that the only special thing we needed to do was add our instrumentation test runner. That's basically everything we needed to do to have Espresso working. And then, well, I've added my Espresso dependency in my build file. This is also one of the things I do. This is not totally default, but yes, you see I include my dependencies from the root project. It's looking like this. It's just one of those things. Quite often we have multiple modules going on in an Android project, so to make it handy to have all our dependencies nicely on the same versions, also if we need to have the definition right, we always list up all our dependencies in our top-level build file. So what you see here, I have all my dependencies nicely listed up. And the libraries, you see that I can also do things like exclusions and so on. And then in all the modules, I can just reference my top-level build file. That way, for instance, if I want to bump up the version of a library, I just go into my top-level file and it's done for all my underlying modules. Now, let's take a quick look. We were running tests, build successful. So we should have a report waiting for us. So, report. So yes, you see my Espresso tests were nicely picked up, nicely run as instrumentation tests. And it was very simple to write them and work with them. Now, you can also use these tests from inside your IDE, Android Studio in this case. So you could just run your tests. You see it's picking them up. It's picked up 5. Let's open up the class. It contains 5 tests. The only thing you need to do special for this one is if you go to your configurations, you see that I have configured the specific instrumentation test runner. That's the only thing I needed to do to have this working in my IDE. So, Espresso working very fine in your normal environment where you do your Android development. Now, it's a little bit over halfway. I would say we could maybe do a very quick break, maybe 10 minutes. Let's get back here, well, 3:20 or something. Now, last year I did a hands-on lab, and I had some KitKats with me for during the break. It only seemed fitting to have some lollipops with me this year. So if anybody wants a lollipop for during the break, just come and grab some. And otherwise, we'll see each other again in 10 minutes. Now let's take a look at another tool. And the next tool we'll take a look at is called Robolectric. Now, until now, we've always been busy writing tests that really depend on an Android device / emulator. That doesn't really matter for this story, but we really needed an Android system. Now, you could always ask that when you're writing just your code, you're writing against an Android.jar file. Why couldn't you just run your tests again at Android.jar file? And well, the reason is here. I've decompiled the Android.jar file, so this is just a normal Java decompiler. So what you see is I've taken a look in the TextView class, and basically the thing to notice is that your Android.jar is only basically all the interfaces, you have all the methods, you have everything to make your compiler and your IDE happy, but this is not runnable code. Android will depend on native services, on Linux code in the end. It will do all kinds of hops, and the Android.jar file in the end is only for you as a developer while you're developing. But the whole file is full width, whatever method you call has a throw new runtime exception stub. So it's really only one big stub for all the Android methods. That's why until now we couldn't just easily say, well, why do I always need to deploy my app and my testing app on an emulator, on a device? Why couldn't I just run it? Because in the end I'm writing Java, I have a Java virtual machine on my computer. Why couldn't I just run my tests on my computer? Because you could say, now it's basically a little bit of a time sink. I always have to do these 2 builds, I have to deploy, I have to run the tests, then my computer needs to gather test results from my Android device. So you could think that certain types of tests could become quite a little bit faster if you did not have to run them on a real / emulator Android device. And that's where Robolectric comes into play. So basically what they do is Robolectric comes with the idea that if you replace the code, which you saw that the normal Android.jar is not enough to run, but if you would replace the behavior of that code, or that also would otherwise have needed a real device, then you could just write plain JUnit tests without having to deploy them on a device. Robolectric does this by through the usage of what they call a shadow class. So basically they mock the implementation of the real Android libraries. Now, you could say, when am I going to use this tool? When am I going to use Robolectric? You could say, well, sometimes you really have some test cases where you think the normal instrumentation test classes are too slow. To be honest, nowadays we have quite capable devices, we have quite fast devices. The whole story about instrumentation testing is also always improving. We see that Espresso has all these tools behind the screens to try to make instrumentation testing as fast as possible. So you really need to think about it for yourself. You really need to think when you've seen what's possible with Robolectric, what are the disadvantages, what are the advantages. You could say, if you have good emulators, like what you have now with the x86 images or emulators like Genymotion, instrumentation testing isn't really a problem anymore. It's fast enough, it's acceptable. That's something you need to decide for yourself. Now, with Robolectric, you can do your unit testing without needing to depend on a real Android device, and that will make it easy and super fast. When I showed you the screen grab of a part of our test suite where we had close to 1,300 tests running in 14 seconds, that's of course the Robolectric based part of our testing. It's running super fast on my computer instead of deploying and running everything on a real device. You can also make your own shadow objects if you have a specific use case. And then one of the big selling points for Roboelectric was, of course, that if you wanted to have JUnit 4 and some of the JUnit 4 tools, then, well, it was just a lot easier to have some of your tests working against Roboelectric. The good news is that hopefully in a few week times, JUnit 4 support will be part of the testing support library. The disadvantage is, of course, that if you rely on Roboelectric, if you rely on running your tests on your development machine instead of on a real Android device, you can't really claim that all functionality is covered. For instance, things like if you use OpenGL, if you do specific stuff with sensors and so on, then you will really need to write some tests that run on a real device, I would say. And also the whole interaction, let's say you have an application, you want to interact with the camera application to import or to make a picture and import it in your application. These are all use cases where I think Roboelectric is less suited. Now, let's take a quick look. Roboelectric, how can we use it in our tests? You already see the add test annotation, JUnit 4 add test annotation. It's, well, it's quite handy to have it now. And for the rest, what do we see is, well, we get a hold of the activity. In this case, we just can pass through Roboelectric build activity. And at that point, we can start interacting with it. So remember now, whenever we do a call, like activity finds view by ID, this is through Roboelectric then passed to a shadow object, not a real activity running on a real device. But for the rest, for us, we are just writing totally the same code. We can do things like interactions with the view and so on, like here we click a button, and at the end we then can quite easily get a hold of results and do assertions at the end of the test. So this is a test that can totally run outside of a real device. How can you set this up? Well, as said, this will only then run on your Java virtual machine. You can use it with Gradle Maven. I'm really focusing on Gradle this afternoon, but for the rest, there's basically none of the tools that couldn't also work with Maven. There is a Gradle plugin available, one from the Roboelectric people themselves. There's also a few other people that have written a Gradle plugin to integrate Roboelectric into your Gradle builds. I think the most well-known one is by a company called Novoda. And on the other side, what I'm going to show is integrating Roboelectric in your setup, all in all, is not very hard. So you could just do it yourself. Instead of relying on an external Gradle plugin, you could also, in your build.gradle files, just write the necessary implementations yourself. And one of the best documentations can be found at the blog of Paul Blundell. There you will see a nice overview and a nice sample project. But basically, the setup is going to be something like this. This is a very simple, I call it my skeleton for an Android application. Basically, what you see is I have an app module at the top. This is basically what you've seen until now, a normal Android project. So that will contain our application code under the main source set, and it will contain everything from instrumentation tests under the Android test source set. Then what we also quite often do is we have an additional module where we only put Java code, so code that doesn't depend on Android at all. So that's what we call the core module. This is a plain Java Gradle module. And then, for instance, and that's what how we do it now most of the time, the Roboelectric tests, we put them away in a separate module. So here in this case called Robotests. For the rest, it's a Gradle setup, as you know it by now, I would suppose. If we then take a quick look at the build.gradle, you see we only depend on the Java plugin. We don't depend for this one on the Android plugin anymore because it's plain Java code. It's going to run on a Java virtual machine and not on an Android device. And then basically, this is all what you need to integrate RoboElectric into your build and your Gradle build files. So yes, you could use an outside Gradle plugin, but it's really simple to do it yourself. And one of the reasons we're doing it ourselves is because it's so simple. Why would I want to depend on another Gradle library? For instance, you see that at a certain point, you need to get hold of the com.android.application module. This is part of the Android tools. And a few months ago, the name changed. It used to be that you apply a plugin called Android, and now it's renamed to com.android.application. If you were depending on an outside Gradle plugin, well, you need to wait until the authors of that plugin do an update. Since we know it's so simple to integrate RoboElectric ourselves, well, this is what I prefer, but you're totally free to do whatever you want, of course. It just allows me to react a little bit quicker when there are updates of certain parts of the setup. So what you see is test compile. This is a change. It used to be Android test compile. This was really to have the Android instrumentation test dependencies. Now, since we're working with a plain Java project, we can apply the plain Java plugin. And if we have dependencies that are only used for testing, we can now put them on the test compile scope. Then for the rest, what do we still need for the setup? Well, a custom test runner. So basically what you are going to do in your custom test runner is tell RoboElectric where your Android manifests are and where the resources are, so that you can also write tests that do certain things depending on the manifest. You can really work with your resources and so on too. This is, well, the most basic sample. RoboElectric comes with a RoboElectric test runner. So that you already get out of the box. The only thing I do is I extend it so that I can tell where it will find the manifests. So this is a little bit, could have been done a little bit better because I have my values here hard-coded in this example, but it's just to get the message across. So I can show the RoboElectric Gradle test runner, which is running in my RoboElectric module. I can tell it where it will find the Android manifest and the resources from the real Android application it's testing. So quite useful, and again, not very difficult to do the whole setup. And another thing is that, this is something you need to know about RoboElectric. Until now, it only supports until Android SDK level 18. So that's really something to take into consideration. And so that's what I configure in the test runner. And then at this point, the test we just took a look at, you see that I can now annotate it with the @run_with annotation. So I say, run this test with my custom RoboElectric test runner, for instance. And this is one too fast. I just wanted to show one more sample. So let's write another test. Let's write another RoboElectric based test. What we see here is how you can interact with an application from RoboElectric, and how, although you are running outside of a real device, it can take the actions and the behavior of a real app into consideration. So you see, we start with a button and we perform a click. Then we get a shadow of the activity, as said. RoboElectric will work with shadows of the Android classes. So I can then ask it what is the next started activity. I will get the intent for that. I get the shadow intent for it, and I can do my assertions to see if everything is behaving as I expected it to behave. And this will run super fast. As said, you can quite easily run 100 tests each second with a setup like this, basically like you've always done your plain Java unit testing. Now, Roboelectric, should you use it? Because, as said, it's a whole activity instrumentation testing. Instrumentation testing isn't so slow. Also, something to take into consideration is if you use Roboelectric, you're really not testing on a real device. So, is that enough as a strategy? And I would say the story is use it as one of your tools, but don't rely on Roboelectric for all your tests, but you're in good company. Even Google has a testing blog where they quite often write a bit about how they do the testing inside. This is a blog post from a year ago where they talk about the testing they do for the Google Plus application. And you see that they also, when they write unit tests, they thought about how will we set it up. And they also use a Roboelectric-based setup for part of the testing. So, as said, hopefully in a few weeks, we will get JUnit 4 support through the Android testing support library, and then we will be able to at last write something resembling this with the normal tools. Now the question is then, well, when should you use Roboelectric? When should you use instrumentation testing? It's a question I can't really answer for you. I can only present you all the tools. What we do is we make a mix. We really want to have some very fast executing tests, and that's most of the time, like, let's say, for instance, a certain intent is coming in my activity or whatever, and based on certain values in it, I want to do something with my state. This is something I would not hesitate to also write a Roboelectric test for it. And then in the end, I will do a little bit more scenario-based tests through all the instrumentation tests. And we think that mix and match and use all these tools where they best apply is maybe the best strategy to do. Now, we were talking about Roboelectric and how you can now also write piece or a certain amount of your tests that run on a GVM. Let's do one more quick detour and talk very quickly a little bit more about an interesting tool for your mocking and stubbing. And the interesting one is Mockito, of course. That's also a very well-known library among Java developers. Good thing to know is that we can also use this for Android development. So basically, if you want to change runtime implementation of objects so that you can have predictable tests that run in isolation, you can use a tool called Mockito. And you can also use it to then verify behavior. So it's, as said, a normal Java framework. The way it works is it wasn't really usable on Android during the first days because it's generating bytecode. And as you know, on Android, we're not using plain old Java bytecode. But a team from Google has coded an alternate backend for Mockito so that it also can generate DEX bytecode. And nowadays, Mockito is also usable for Android development. And so basically, you can use it to mock dependencies for your objects and also mocks the returns or the values that you return from functions and so on. It has a good site with quite good documentation. But let's take a quick look at how we can use this in Android development. And basically, I've highlighted the interesting functions here. The thing to focus on, the Mockito code, is you can now, for instance, say, if you use a good tool like Mockito, when this function on my mocked converter is used. Oh, basically, I've missed this one. You see that if you want to create a mock of an object, you can just use the mockito.mock and you supply it the class, for instance. You can also work with annotations, but this is just a sample. So now I can say when a certain function is called, then return my expected value. I work with my mock, and at the end, I can quite nicely do verifications. So I want to know, Mockito verify, that on my mocked converter, a certain function has been called, and I can also do verifications like it should only be called once, and so on. You can also do certain methods should never be called, and so on. So it's really a useful tool to work within your unit tests. To take a quick look at Mockito. Now, another tool I quickly wanted to show is the monkey. Everybody likes monkeys, unless it's more of an evil monkey, and that's really what this tool is. The monkey is a tool that you can also find in the SDK, and you can use it to generate random events and blasting them into your application. So that can be clicks, touches, certain gestures, and so on. It will really do a stress test of your application, and that's sometimes also what you want to see. You really want to do a stress test. You really want to see if your application will not crash under, well, what I think are unexpected behavior that the user is doing. So instead of having your tester, everybody knows it, you give your device with the app you made to the tester, and instead of nicely looking what you did, he's going berserk and seeing if you don't have missed an edge case. You can try to prevent that scenario and do some monkey testing yourself. So it's a command line tool. It's a very simple tool. It has very simple configuration. Basically, you can tell it a little bit about how many attempts, how many events should it try to generate randomly. And this is also a good one. Most of the time, you will restrict it to your own application, of course. It shouldn't go outside of your application. You should really try to stress test your whole application. So the command to use, the simplest version is you just use the Android debug bridge. So you just say ADB shell monkey -p, you give your package name so that it doesn't get out of your application, and then -v, you say how many random events it should generate. Now, the interesting thing is, of course, when the monkey can crash your application, so it's also possible to give it a seed value. So you are guaranteed that with a certain seed value, it will always generate the same stream of events. So that's handy to know, because if you see a crash, you can at least generate the same new stream and you can start debugging and so on. But can maybe take a quick look at the monkey. So I have a device. Let's take a look at this Big Bang app. So it's a very simple application asset. I just have a mirror, of course. I have a very simple application, and you can click and then you see details of a person. So let's release the monkey. And here my monkey is stress testing my application. And now let's hope my application doesn't crash. It didn't look like it. Oh yeah, I have verbose logging on. But this is a way so that you can stress test your application. You should do it from time to time. And sometimes you will find out some edge cases. Let's quickly restart my emulator. Anyway, you can do a few runs. You can give it a nice amount of events. And you see it's staying inside my application, but it's doing whatever random stream of touches and whatever it can come up with. And this time I've done 2,500 events and my application didn't crash. So it's a useful tool. Run it from time to time, and sometimes you will find an edge case you didn't think about.
You need to see where your application crashed?
Well, yes and no. The monkey is just a tool that will generate all these random events. So that's why I normally would always run it with a seed value. So when I see a crash, I can re-trigger the same stream of events. And then, of course, I will have my logging. I will have my logging going on, so my logcat. So maybe I can see something there. And otherwise, most of the time, that will be enough to start really getting down in your application. And when you see where it's crashing, you can really start a drill down, maybe add a little bit extra debugging info and so on, or maybe even add breakpoints. Because if with a seed value, you can make sure that the same stream of events is always going on. You can quite easily debug. If you just have the application running, you can always connect to your application. You attach a debugger, and you can see whatever is going on. So yeah, I would say it's quite easy to debug if you have a crash with Monkey. Now, that was it for the Monkey. Another tool, a friend already hinted at it, Assert J Android. Again, another library you can use to have a little bit more readable tests. Really syntactic sugar, but it's really helpful. It's an extension of the Assert J library, which is plain Java, and this is really an extension to make it super useful for Android development. So it's a fluent syntax to make assertions. It's another tool, one more, that's coming out of the Square Camp, who have lots and lots of super interesting and useful Android and also outside of Android related libraries. So we can find their documentation and website and a little bit more examples on GitHub. But basically, the problem they are solving is this one. Say you want to do assertions, so during a test, you want to assert state and so on. The upper one is how we would do it until now. So, for instance, you want to assert the visibility of a view. We all know that you can have visible, invisible, and gone. Android works with these nice integer constants instead of an enum. I know there were reasons for that. It's mainly a performance related story. Nowadays, with the new runtime art, it's not so necessary anymore to pass around all these int constants and so on instead of enums. But okay, in the Android platform until now, we're stuck with it. So you get code like this. You want to assert the visibility of a view, and then, yeah, hopefully you know where you can find the constant. But you get code like this: assert equals view.gone, view get visibility. With a tool like Assert J, you can say assert that view, and at that point, you get all kinds of assertions that apply to a view. So one of the things you can do at that point is say assert that the view is gone, for instance, or visible, and so on. So it's really, really helpful and really nice syntactic sugar to add to your tests, a tool like Assert J. And not only when you write tools, but it's even more useful when something, again, is going wrong. Let's say you have, until now, written some tests. A test fails, and you get an error message like this: expected 8, but was 4, because all these integer constants behind the screens. This is really helpful. Expected 8, but was 4. You can go clicking around, viewing documentation, and so on. With a tool like Assert J, you get a very nice error message saying expected visibility gone, but wasn't visible. So it's not only helping you write conciser code, it's also really helping you when something goes wrong and when you want to know what the error in your test was. You can take it a little bit further, like this is another example from the SRJ Android documentation. Let's say we have a view and we want to check a number of properties of it. So let's say, for instance, we start with checking the visibility. After that, we check that the orientation is vertical. We check that it has a certain number of child views. And we also want to take a quick look in the dividers. You see, this is quite hard to read. Also quite hard to write. You need to know quite a lot about your code and so on. This is the equivalent if you use a library like assert.j. So we can just say assert that layout. At that point, you get all these assertions that apply to this component. So you can then say assert that layout is visible, is vertical, has a certain child count, and has show dividers. So really, really helpful for readable code. So absolutely one of the libraries you should put in your testing toolbox. Now, another thing to talk about is testing of your network resources. A lot of apps do something with a backend, but let's take a quick look and how can we go a little bit about a testing strategy for your networking resources. So I would say there are a couple of options here. You could, of course, start thinking about, well, what is unit testing versus integration testing? I think both apply and both are necessary. So if you have a component that depends on a certain service that does some networking calls, you should be able to nicely isolate everything and say, I'm going to now focus on this component, mock away all the dependencies and so on. But at a certain point, I think you also will want to have a few integration tests that go a little bit further, that are a little bit more higher level. So what can we do here? Most of the time, for our projects, we always use retrofit as a networking, as a REST library. I think it's quite a popular one. So let's focus a little bit on retrofit while talking about how can you set up some testing for your networking. Now, first question is, would you hit a real server? Maybe make it a question. Who thinks that just calling your normal servers is the best idea from your tests? Yeah, it was a bad question. I really didn't expect any hands to show, but this is really introducing another level of, well, it's another reason, another one of those reasons which can make your tests a lot more brittle. If you depend on an outside server, it's really, there it is. It's really a source of additional problems. For instance, let's say the server is down or the server is not very well reachable. It could also be that there's no problem with the server at all, but the network you run and running your tests has a problem and so on. So it's not only a source for brittleness, it's also a source it's also one of the reasons that can make your tests very slow. If you always need to travel across the real network, that can really make your tests a lot slower. So that's another reason why I think you shouldn't do it. It's also sometimes very difficult to test certain scenarios. For instance, let's say you are talking with a real backend. Well, then I think it's very difficult to simulate certain problems. For instance, let's say you are working with an outside service and the API has a certain limit. How can you simulate that that limit has been exceeded if you're working against a real server? So I think all these reasons, all in all combined, are really a testament to never hit your real service from your tests. It's also sometimes in Android we all know that all your networking calls should be asynchronous and so on. So that's an additional difficulty that's introduced that we can take a quick look into. I think there are two possibilities if you want to think about testing your network resources. And you can mix both of them, but I think that the two possibilities are you can use a server, but not your real server, but you will see a good testing scenario where you use something else but a real server so that you are really stressing your whole HTTP stack. And at the same time, hopefully, and with a library called Retrofit, it's very well possible, you can also nicely mock away your retrofit interfaces so that you can really do like an integration test, but you're not hitting real servers. Now, let's take a quick look into the two scenarios. Using a test server, what are the pros? Well, if you just have your application and instead of talking with a real backend, you have somewhere a test server that you can quite closely, place quite closely to your test app. Basically, you will not have a lot of changes in your app. It's gonna amount to just changing the URL, and that's gonna be it. So very few changes to your app. And also a very good trait of using its server is that you can start sharing it with other teammates. For instance, I'm now working on a project where we're working on Android clients, iOS clients, and a mobile website. We have a certain test server, and we can quite easily hit it with the 3 teams. So that's quite nice. One of the teams did the effort, but there are 3 teams that can work with this test server. Another good trait of a test server is that when your real backend, when the guys making the real backends aren't really far ahead of you, or when they are not just fast enough making these services available, you can try to mock them away in your test server, and then when the real backend is ready, you can just switch over. Of course, it's still another dependency, so still another thing that can fail during your tests. That's really a disadvantage. It's also, well, still a new thing, still something you need to set up. And what is very difficult sometimes to test is then when you need state. Like, for instance, you do a payment, and then you do a second call, get me all the payments. The payment you just made should be in the list. So the test server should have the possibility to add some logic too. And still, well, it can lead to slow test execution. You are still talking over a network. On the other hand, you can, for instance, if you work with Retrofit, you can nicely mock away the interface. So really, you create your boundary before the HTTP level. And that will also make it easier. Let's say you want to test some state. If you delete an item, you do a requery of a collection, it's just easier to work with it. But it also means that, of course, for a test like this, you trust that whatever Retrofit is doing behind the HTTP boundary, your JSON deserializing and so on, you trust that it's done well. What you are doing is mocking out, really just serving the data. So the pros are definitely that super robust because if you are not traveling over a network, you won't have network errors, timeouts. It's also very easy to really mock all your different edge cases and all the scenarios you want to do. And basically, in the end, your dummy data will just be some Java that you write, so that's very easy. The disadvantage is, of course, well, yeah, you also need some extra code, and you don't really test the JSON deserialization. That's why I would always then add, if you do something like this, you should maybe add some unit tests that really test this part in isolation too. And of course, this doesn't really constitute a real integration test, so maybe you need to mix both approaches. Now, mocking a network interface with Retrofit, there's a very good example in the Retrofit documentation, which you can just find as part of their repo. So I don't need to go very deep into it. Basically, the sample is, say, you want to use a certain API of GitHub. You want to get a list of contributors to a certain repository. This is how you could write the interface for the service. So here we have we can make a call so that we get a list of contributors. If you then say, I want to now write a few tests where I mock away this whole network behavior, the way you could do it is like this. So you say, I'm going to write a mock implementation. I implement my GitHub interface. You see, I'm making some stub data. And then the clue of story is you implement the method to get your list of contributors. And at this point, you see, I've highlighted it in bold, you can make a mock REST adapter based on your real retrofit REST adapter, and you can use that to instantiate your mock objects and get your mocked data. So that's really, I think, one of the good approaches that you need to be aware of if you want to work. If you want to test your networking, a part of your tests could also mock away the whole retrofit interface. On the other side, if you want to say, I want to do some real integration testing, then it's maybe good to look at, I didn't come up with a better name, but with a fake real server. Basically what I'm meaning is, you have a server which is really gonna give you back some data for all your API calls, but it's not a real server. It's something you have under tighter control, at least, than a real server, and it should be something which has less chance to introduce network problems and so on. What we do on my current project is we've written something ourselves, super simple, just I would say 20 lines of JavaScript, simple Node.js-based server. What we do is we have a whole list of test fixtures. So, for instance, we say, now we want to work with a certain set of data. We can supply that name of the text fixture to a call, and then the simple Node.js-based server will look up through a list of folders full of pre-canned JSON data and will just return what we need. For us, it's working. It's very simple. But if you don't want to set up something yourself, or if you want something that's quite more capable, a very good tool or a very good library to know about is called WireMock. WireMock is a tool made by Tom Akelhurst. It's a simple test server. So you can use it to, you can configure certain requests and responses that should happen. And that will help you to write tests that are real integration tests and still are quite predictable. A good thing is that you can also work with state. So you can do things like you have a certain begin collection, you can delete items, or you can add items and so on. It's all stuff that you can mock up in WireMock. So it's quite a capable tool. It's non-Android specific, so that's also a good thing. If you do the investment in a tool like WireMock, you can again share it between iOS, Android, whatever teams you have that want to have a testing backend. And basically, it's an HTTP server. It's basically based on Jetty. And you can configure all the responses it should give for all the requests. So how you work is you can work with a JSON API. So it has a certain endpoint called admin mappings, and then you can just post certain JSON, and that will be used as the configuration for, okay, for this type of request, I need to send back a certain response. You can also load up all these JSONs in a pre-configured folder, so that's also a possibility. And you can either configure it with this whole set of JSON configuration, but it also has a nice Java API. So that's also possible. And again, you all know Java, so it's maybe more useful to use the Java API. Now, the way it works is, shouldn't click twice. This one. So you can just post a JSON object, and you see that here I say that when I get a GET request through a certain path, in this case API my test, then I expect WireMock to return a response with a certain status code and a certain body. So very straightforward, very easy to configure request-response pairs. You can also do it from Java. So then it's looking a little bit like this. So you say step 4, a get with an URL equal to whatever path you want, will return a response with a status code, in this case, for instance, a 404, with a body that says no content here. So also very easy. If you write a test, you can have your server spin up. It's very lightweight, so you can quite easily say for each test, an instance of WireMock should spin up, and at the end of the test, it just goes down. And you can quite easily, in Java, write up what you expect, what should happen. So let's take a quick look at how a test could look. I'm too fast here. So here, at test, we are going to write a test. What will we do? The only thing to take into account in this case is we will need to make sure that we do requests to the URL and to the host. Basically, more important, the host and the port where WireMock is running. By default, it's going to run on a port 8080, but you can all configure that in WireMock. And there could, for instance, be, if you're an Android client, you could just make a flavor dedicated to this testing. But let's take a look in this code. What could you do if you use WireMock? You could quite well readable say, step 4, a get requests at the my resource will return a response with status code 200, all okay, and a body, certain response. And then, for instance, I could say in my UI, okay, I'm going to go on view with ID submit button. I will click that button. I know that behind that, it should do all kinds of work. It should call my API. It should do something with the response. And after that, I want to take a look, and I would, maybe something went wrong. I gave a bad input, and then I would be able to say, on a view with a text error message, check that this one is displayed. This is all very readable, and now I have an HTTP server really spinning up, running, serving my responses, and in a very nice and easy and readable way. And by the way, WireMock also gives you the ability in this kind of scenario to do verification. So at the end, I can still say, verify that, for instance, a post has been requested for a certain URL. So you can also check that your application shouldn't have called this twice or whatever. So it's a nice testing tool to have in your testing belt. The good thing is also that you can, as I already hinted at, you can work with stateful scenarios. So if you're making a banking app, if you do a payment, and then you do an additional request to get a payment overview, your new payment should hopefully then be in your list with payments. So you can set up a scenario like that with WireMock. It also has support to simulate certain errors, delays, and so on. Maybe you could introduce a very long delay and then see if your Android app still behaves the way you want, and so on. You could, if you introduce very long delays, nicely check if the progress indication you do is well, and so on. So one of the ways you can run it is you can run it with your test device, and more in a minute. But you can also run it standalone on your network. For instance, you can share it between a team. So that's also possible. Of course, remember that WireMock is stateful, so maybe then you should more look into separate instances for everyone, but it's possible. So, like I said, we made something ourselves, but we could have just as well went with WireMock and used that for a whole set of integration testing. And also during development, when the real server, when the real backend isn't ready yet, we could use something like WireMock and have it serve already the data we want. So you can also run it as part of your testing application. The only thing is that out of the box, It's not possible yet. You will need to take a look through the documentation and the news groups of WireMock, but it's possible to set it up, but better support is coming. So at that point, you will really be able to have a test server in your app. Now, we're nearing the end, but a small detour I still wanted to make is, well, all fine and well to know now about a lot of these testing tools, but maybe let's think for 2 minutes about the application and the code and how you structure everything yourself. Because I think if your code base is what we call spaghetti, then it will also be very hard to test. I would almost go as far as say that if your code isn't really testable in a nice and easy way, then that should make you think about the structure and the architecture of your application. I really think that good code almost equals testable code. I'm quite convinced of that. Now, when we talk about design patterns, the only one I would like to lift out is dependency injection. Of course, you should do it well. Otherwise, you will become the subject of tweets from Romain Guy. It only seemed appropriate because it references his talk from last year here at Devox. But I would say if you use DI, one of the most well-known ones on Android is Dagger. And that will really make it possible for you to have, well, if you work with dependency injection, you should nicely be able to always, when you do tests and isolation, to nicely mock up whatever dependencies all your objects have and so on. And I think with a tool like Dagger, it's really very well possible to make a good architecture. Now, I'm not really going to talk a lot about Dagger because, first of all, there's a very good talk that was on last year's Devox by Jake Wharton, and it's on Parlays. So you can take a look. It's a super good introduction about DI and Dagger. And what's even more is if you're here all week, there are a few sessions I can suggest. Tomorrow, there's a hands-on lab about Dagger 2. And on Thursday, there's a talk by Jake Wharton, again, about dependency injection. So I'm not going to go on too much about architecture and so on. There are really a couple of super interesting talks that you can go the rest of the week. Another talk I would like to recommend is How to Build Rock-Solid Apps by Jordanis. He works at Shazam. I've seen his talk already. And if you're interested in Android and testing, if you still are after this session, I would really encourage you to go because it's a story how they, which have an application that's running on, let's say, millions of installs by now, how they thought about their testing and what tools they use. They also have a few, well, custom tools they've made. And the second part of the application is also where they are talking about how they should think about architecting the application so that it's well testable. So if you're interested in Android testing, it's definitely a talk I would also recommend you to visit. It's a good one. Now, in the end, let's bring everything a little bit together and talk a little bit more about how can we now automate all this and maybe also get a little bit of reporting out of it. First, I want to talk about this. Well, we were now always writing tests and always running on one device, and that's all very handy and something that from now on I hope you will do every day of your developer life. But in the end, the real value of having these whole test suites is, of course, when you can run these in a distributed way, and of course also in an automated way. So you will want to do some testing on multiple devices. How can you run all this? This is, well, if you don't have all these devices, and that's sometimes very difficult, like I know now that where we are, we have quite a nice set of test devices, but still there are a couple more I would want to have. There are also services available where you can, for instance, online connect to external devices. So that's also possible these days. So let's say you've worked quite hard on your application, you've done the work for testing, but if you want to be a little bit more sure at the end of the project, you can also farm out and, for instance, hire a couple of hours on tens and tens or even hundreds of different devices. These services exist. And apparently on the inside, they look something like this. And then, of course, it would be nice if you run all these tests on multiple devices, if you would be able to get a few reports and logs captured. And then another thing that's quite good is if you would have the possibility to take screenshots from time to time. And I really think that's handy because not only is it nice to have good visual feedback, but it's also a good thing, I think, if you start sharing that with your designers. If you, for instance, run tests on a whole set of devices, hopefully different form factors and so on. If it would be easy for the designer to get from time to time a very quick overview, like let's say a dashboard where you can see, oh, on a small tablet or on a small phone, the layout is totally off. I think it's really helpful if you can set up something and share with your designers. Now, another tool I wanted to quickly mention is Spoon, and that's basically a way how we can automate the test execution across a whole set of devices. And not only is it capable of running all these tests, it's also quite a good tool if you want to aggregate on all the results and so on. Again, it's another tool coming from Square, super handy. And it looks something like this. Okay, I was talking too long, battery is gone. Anyway, this is what you get from Spoon. So Spoon is going to take care of doing this distributed running of your tests, and it's going to generate a very nice overview and dashboard. So basically, but we still have the time to take a live look. So they do have a sample. Here it is. Now, let's share this one. So this is basically what you can get from Spoon. So a nice overview. In this case, you see that there are 8 devices. And so if you have 9 tests that you can run across 8 devices, you can see some interesting things popping up. For instance, here they have a test which is only failing on 2 devices. Can be interesting. It's not failing on every device. You see that you get a quite nice overview, so you can nicely see which test is failing and so on. Now, you can drill down for every device. You can also drill down on a test. So in this case, you see test results. You see that's very nice. You get, in this case, screenshots. So we can follow along a little bit what has happened. Very useful too is that you can get a device log. So Spoon will try to capture the logging through logcat that is going on. So for this case, these are the logs. So that can also help you quite well if a test failed, and you can directly from your dashboard try to drill down a little bit. So quite a useful tool. You can also get an animated give-off and so on. So if you make a scenario, you can really follow up what is going on. So basically what you can do is you can do a drill down either per device. So you nicely see which test is failing for a device. You can drill down through a specific test so that you can see just the opposite for which device it's failing. So, and in the end, you can also quite easily make screenshots. So, very handy tool to have. And the sample I showed you can be found at the Spoon GitHub site. Now, in the end, let's bring all this a little bit together. So we're making software. We're talking about what we call a build pipeline. Basically, I hope that you can get towards a scenario where each time you do a commit, you can pass through a whole automated testing stage. There is still room at the end for a real tester, but I would like real testers to do intelligent work, really drill down, really see edge cases and so on. More so than doing the monkey work. We have a tool for that. And so in the end, I hope now that if you think about the whole pipeline of software development, you can see how for an Android app, the testing steps can be done. There's still a lot you can say for the other steps, but I hope that you now have a little bit better overview of what you can do if you want to fulfill the testing steps. So that if you set up your whole development environment and your whole strategy, how you work, that you should have now an idea about the tools that you can at least use for testing. And in the end, I think this can all come together in a sort of continuous integration setup. That's also possible for Android projects, as you without doubt know from other types of projects. So when you have continuous integration into place, you can really go to a setup where you get a lot and lot faster feedback, so that hopefully every commit in the end can be tested. When something is wrong, you immediately get feedback. Of course, if you have some long-running tests, you could just as well set it up that certain tests always run, others should run from time to time or each night or whatever, so that hopefully you can get into a setup where a lot and lots less manual testing is required. And of course, one of the big additional benefits of having a good test suite is, of course, that you have regression tests. When you are working on a new feature, if you have this whole, if you have all these other features with a good test coverage, you can quite well and quite reliably know if, while working on a new functionality or while doing a big refactoring, you didn't break some other features. So one of the tools you can use is Jenkins. That's quite a well-known CI server. Here you see, for instance, a few Android projects that have been configured. So it's very well possible to do a setup like this for Android. And that can give you a quite nice overview. This is, for instance, even a Maven-based build project. Nowadays, I would really stay with Gradle, but if you have the requirements to use Maven, it's no problem at all, also with Android. And so that you can end up with a good continuous integration strategy. Now, there are lots and lots of servers that are available for continuous integration. I think the most well-known ones are Jenkins, Bamboo, and TeamCity, and so on, and that's all possible to use for an Android project. I would just quickly want to point out that there are also hosted versions. So, for instance, there exists a company called Travis CI, and they have basically a hosted version of continuous integration. So even if you can't have the resources to set up a CI system for yourself, it's still possible to go towards a hosted solution, and then you get something like this. This is, for instance, one of our projects. So you see, I'm just online, and I can just have a hosted version, a hosted CI system, do my Android builds. I can, well, let's take a quick look. You see that it's also starting up an emulator and so on. So if you're doing Android development, you have done the effort to write some tests, and now you want to go towards a whole automated CI setup. It's even possible if you can't have your own server. Systems like Travis and so on are available. Now, good to know is that a little bit later tonight there's a session about CI for Android, so I'm not going to go on about it. If you're interested, a little bit later on tonight you can visit another session. And then just basically to end it up a little bit, we were writing tests until now. And super nice that we've gotten known all the most useful tools on Android, and we've seen that all in all, testing might be a new thing that you need to learn, but it wasn't so difficult that you should think, I can't do this. But while writing tests, it's also very nice if you get some sets of metrics, if you know how much of your code has been tested, which parts has been tested well, which haven't, so that you can feel more safe about your testing. I mean, if you only tested one part of the application, but all your banking or payment logic is in another part, and you haven't written any tests for it, that would be nice if you could get some metrics and an overview, and that's possible. One of the tools you can use is called Yakoko. It's an open source toolkit to do basically code coverage reporting. It's also the tool that the Android tooling team has chosen. You see the release notes for, and that's already a little bit older version of the Android Gradle plugin, but you see that they are also working on Yakoko integration, and this is a screenshot from my current project. I've blurred out the package names to protect the innocence, but the thing is that this is the overview, and the only thing to know is we have a coverage of 88%. What percentage of coverage you would like to have, that's something you need to decide for yourself. But the thing is that we can very easily do a drill down through all our packages, through all our code, and see where we have done the necessary effort or where more effort is necessary. So the most important parts of the application are definitely tested by us, and the parts that are not tested, the parts where you see some red showing up, this is really a deliberate decision by ourselves. We know that these are the parts that either don't really need tests by us or that are really less important and so on. The percentage, don't stress about it. I don't know what a good percentage is. It's something you need to decide between the members of your team, I suppose. I think 88% is quite a good one. So basically, that's it. We talked a bit about Android testing. We saw the main, and I think the most important testing frameworks. We saw how it's basically, let's be honest, nothing to be scared about. Quite good tooling already, and you've heard that Google is working and made a promise to work even harder on good testing support. I really hope that I could convince some of you, if you're interested in testing, that also on Android, it's very well possible and it's even enjoyable to do. So I would like just to end up with a couple of references. The thing is that there don't really exist good books about Android testing. There are a few ones, but like the first one I would say is quite out of date already. The Busy Coder's Guide to Android Development is just, it's more than 2,000 pages, but it has some good chapters on testing too. But I think the bad news is that Android testing is still looking out, searching blogs, searching presentations, searching videos from conferences and so on. It's very well possible, better and better documentation is showing up, but you will need to do a little effort, I would say. On the other hand, testing is a very well known subject, so really there are lots and lots of good books available on testing, lots and lots of good books about Java testing. The good thing is that you use Java for Android development, so lots and lots of general purpose Java tools are available to you, documentation is available to you, so don't be stressed about it. I think picking up all the necessary skills for testing on Android is quite easy to do and enjoyable. So basically, that concludes my presentation about Android and testing. I hope you found it a little bit useful. And if you have any more questions, feel free to shout them out. Half an hour? Sorry, I don't see you. Okay. As far as I understand, all slides will come on parlays anyways. But if you look for my name, I will make sure that tonight they get posted. Thanks.